Okay, we're going to go over factoring by using some special factors. This is what this is known as. We're going to start with the special factors, okay? Which means we're going to look at the difference of perfect squares, the difference of perfect cubes, and the sum of perfect cubes. We're going to be using these formulas in factoring, and then we're going to move on to factoring by what I call the crisscross method for trinomials. So let's kind of do some quick review here. And what we can see is what we call the difference of perfect squares, because x squared is a perfect square. So this first term is a perfect square, and the second term is a perfect square because 1 squared is 1, and then there is a difference. So by using our difference of perfect square formula, we have this a squared minus b squared is the sum of a plus b times a minus b. What I would like you guys to see is that the value for a here is x, because you see an x squared for that first term, and the second term would be 1 squared. And so this is what we're seeing here. By letting the a and b values be what they should be, that means a is x and b is 1. And so when you factor, this will be x plus 1 times x minus 1. Just go back and let the value of a and b be what it should be. So there you go. It's the first special factor. And this goes back to beginning algebra. Okay. And we're going to do this over and over again. Because even though we know x squared is a perfect square from the last example, 4 is also a perfect square. You see, anything that we raise to the second power, and sometimes I just put like a triangle, anything that we raise to the second power is called a perfect square. The triangle is the base, by the way. So it's called a perfect square. That means x squared is a perfect square. 2 squared is a perfect square. So we got the difference of perfect squares here. So using our formula, x, 2, and 2, because it's x squared minus 4. We have now factored by the difference of perfect squares. All right. Number 3, x squared minus 9. Well, 9 is 3 squared. So again, the first term is a perfect square. The second term is a perfect square as well. So using our difference of perfect square formula, x squared minus 3 squared, where x is a and b is 3. Add, subtract. We have factored the difference of perfect squares. X squared really minus 9, which is 3 squared. All right. X squared minus 25. Well, again, we see that we have a perfect square being x squared and 5 being, or 25 being 5 squared. So we get the x squared minus 5 squared becomes x plus 5 and x minus 5. Just plug in those values here. X, 5, x, 5, 5. You have factored again the difference of perfect squares. Four x squared minus 9. Okay. Now, remember, any base to the second power is a perfect square. Four x squared. 2x to the second power. I want to remind people that this notation is really exponential notation. This is repeat multiplication, where your base here is what's between those parentheses. So this becomes 2x now times 2x. And the order in which you multiply doesn't matter. And actually, I'm going to remove the parentheses. I can do that. And now I switch the order. So in case you guys forgot, this becomes 4x to the second power. So how that works for us is to notice that, again, 4x squared is a perfect square. 9 is a perfect square because we write that as 3 squared. So a now, if I look at it this way, 2x squared minus 3 squared, well, my a term is 2x. The b term is 3. And again, it's plus and minus. So what you're really looking at is the phrase 4x squared minus 9 that was given to you on that left side. And that will be 2x plus 3 times 2x minus 3. And this is how we factor the difference of perfect squares here. Similarly, 9x squared is a perfect square. 25 is a perfect square. So for 9x squared, we can write that as 3x to the second power minus 5 squared. So perfect square here, a perfect square over here. Just make sure you put 3x for the a value, and then you're going to put a 5 for the b value. Plus and minus. And there you go. Number 7. 25x squared minus 4. So 25x squared is written as 5x to the second power, and then the 4 is 2 squared. So again, notice you have a difference of perfect squares again. So 5x to the second power minus 2 squared using your formula. 5x plus 2. 5x minus 2. All right. Okay, now we're up to working with what's called the difference of perfect cubes, and there's a difference of perfect cube formula. So x cubed here is a perfect cube, and you might say, what is the definition of a perfect cube? Anything that is raised to the third power is a perfect cube. And 1 is a perfect cube because 1 cubed is the same as 1. So like before with the difference of perfect squares, you can identify that if I replace a with x and b with 1, that means a is x, b is 1. We write this as x minus 1, x squared plus x times 1 plus 1 squared. So you got a cubed minus 1 cubed here, right? Or minus b cubed, but all right, difference of perfect cubes. We just have to simplify the quadratic here because x times 1 is just x, and then 1 squared is the value 1. So we're really factoring again a difference of perfect cubes now, and you do have to identify that you're in now the world of perfect cubes as opposed to perfect squares. You have a difference of perfect square formula, a difference of perfect cube formula, and then you're going to have a sum of perfect cube formula. But you're going to just replace those values with what they really are, a, b, and use your formula, use your factoring formula. Similarly, we got the sum of perfect cubes. Because 1 cube is the value 1. Perfect cube, 1 to the third power. All right. So replace a with x, replace b with 1. So you really have a cube plus 1 cube will equal x plus 1, x squared minus x times 1 plus 1 squared. So just like before, simplify the polynomial on the second term here. So ladies and gentlemen, you now get the sum of perfect cube factored. Here's another sum of perfect cubes. Because 8 is 2 to the third power. That's a perfect cube. We already know x to the third power is a perfect cube. We now know that 8, which is 2 to the third power, is also a perfect cube. So again, a is x, but b now is 2. So just replace your a's with the x and your b's with the 2's. So you'll get x cubed plus 2 cubed, which is 8, which is x plus 2, x squared minus x times 2 or 2x, and then you say 2 squared, which will be 4. So you can put 2 squared there, but very often we just square that, and you now have the value 4 here. So you use the sum of perfect cube formula here to factor. All right. Difference of perfect cubes now. Because like the last example, x cubed is a perfect cube. The number 8 is written as 2 to the third power. So the number 8 is also a perfect cube, but we represent it as 2 to the third power. Just let your A be the value x and B be the value 2 like you did in the past, and you say x, 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 2, 2, and 2, so that you really have x cubed minus 2 cubed written as x minus 2 times x squared. And I'll go through the details with this one, but just to remind people that you're just going to do a little simplification here. X times 2 is the same as 2x, and then 2 squared is the value 4. So I'm just saying you're doing a little bit of the simplification here and here, just like the last example. But this is the difference of perfect cubes. And this is the third formula that we are studying here in this review from beginning algebra. So there you go, ladies and gentlemen, how to use this formula to factor. Okay, 8x cubed minus 1 now. So going back again and reminding people, any base of the third power is a perfect cube, and that, by definition, though, is repeat multiplication. So you're going to have here a perfect cube. We know 1 is a perfect cube because 1 is written as 1 to the third power, a perfect cube. Although you may have forgotten that 8x cubed we can write as 2x to the third power. Let me verify that 2x to the third power now is a perfect cube for you. Okay? Drop your parentheses. And then the order in which you multiply does not matter. I can switch my order to put all the 2's on one side and all the x's on one side. And then you get 8x to the third power. So, sure enough, we have a perfect cube here. So let's move this down and let's use this information. You say, how do I use it? This is what we're saying. That the A value right in here gets replaced with 2x. So wherever there's an A, replace it with a 2x. And then wherever there's a B value, replace it with the number 1. So this is a 1, a 1, a 1, and a 1. What you're really looking at is 2x cubed minus 1 cubed is 2x minus 1. 2x squared plus 2x times 1 plus 1 squared. So the work over here now, 2x raised to the second power becomes 4x squared plus 2x plus 1. So just do your multiplication over here and here. So 8x cubed, excuse me, minus 1, using the difference of perfect cube formula becomes what you see here. All right. Let's see how this all works here. Now, altogether, 27x cubed is a perfect cube, by the way, because this is now 3x to the third, 8, another perfect cube, is 2 to the third power. So 3x to the third power plus 2 to the third power becomes, again, a gets used and replaced here with the values you see, meaning a is 3x, and then b is 2. So we're going to say 3x plus 2 times 3x squared plus, we're going to need more space, three x times 2 plus a2 squared. So you get 3x plus 2. Now doing your arithmetic here and here and here to simplify that expression, you'll get 9x squared plus 6x plus 4. So yes, just plug in the values where you need to plug them in. And that now leads us to the next kind of questions known as the crisscross method, right? You're going to factor now a trinomial. There's 3 terms now. Ax squared plus bx plus c is it's called a trinomial. So we really need to know a couple of values here. I'm going to say focus first on, for these kind of questions here, you're going to consider the a value and the c value. You're going to take that product of those two numbers, and then you're going to notate what the value b is. This is what we do in the crisscross method. However, if you look at the first example, you may say, I don't see an a value, and I'll say use the number 1 for a, because 1 times anything is itself. So you do have an a value, you have a b value, and a c value. So the first thing you want to remark is that 1 times 6, this is what we're saying over here. You find that a times c, 1 times 6, which is actually 6 now. And you just notate your b value, which is 5. And so go with what you see here, where you have to find 2 numbers whose product is 6 and then whose sum is 5. So sometimes what I do is I'll write it down. What 2 numbers has a product equal to 6, yet a sum equal to 5? Now that's what we need to find. We need to find 2 numbers, and we're going to put them here and here, whose product is 6 and whose sum is 5. So we'll know, or we should know by trial and error, 3 times 2 is 6, and then 3 plus 2 is 5. So you might want to verify that. 3 times 2 is 6. 3 plus 2 is the value 5. So these are the numbers. All right, we need 2 numbers whose product is that 6 and whose sum is 5. Now, I want to point out something too as well. A here is the value 1. That first term is 1. When a is 1, like in this case, you're actually done factoring. That your answer will be, if we put this in our answer form. Okay. Because that first number was a positive 3, we just put x plus 3. And because the second number is a positive 2, we just put x plus 2. So what I want to remark to you guys is the numbers that you found are in your answer. And so we could just simply say, okay, this is x plus 3 times x plus 2 when factored. And there you go. Easy peasy lemon squeezy. This is the crisscross method. Okay, let's repeat the process. Remember, we're clearing out the cobwebs. We're doing a review. This is our A value, B, and C. So I just want to remind myself, okay, A is the number 1. That's going to make things nice and simple. So 1 times negative 8. 1 times negative 8 is negative 8. So 1 times negative 8 is actually negative 8. 8 times C. It's negative 8. B, that value here for B is negative 2. So I'm going to put this down over here. All right. Because that's the B value now. So when we use this information, here's what we're going to need to find here. Two numbers now whose product is negative 8 and whose sum is negative 2. Those two numbers will go right here in our crisscross method. So two numbers multiplied together is negative 8, but when added is negative 2. Now, the only way you can multiply two numbers and make it negative is if one of the numbers is negative. That's what we mean. We need the product here. This is a trinomial now. And so if you go through the different trial and error pairs of numbers whose product is negative 8, you might conclude that negative 4 here times positive 2 certainly is negative 8, but if we add these numbers, is it negative 2? And the answer is yes. So the pair is negative 4 times positive 2. Those are the two numbers. And because A is the number 1, we're actually done. We have factored this, meaning we can write this down as, let's put this in the answer form, x minus 4 times x plus 2. It's these numbers here. And you're done. X minus 4, x plus 2. So I want to kind of emphasize that for you guys here. And you have factored. Okay. Crisscross method. A here again is the value 1. So I got A, I got B, I got C. A, C. 1 times negative 3. Right here. So we got the product here going to be negative 3. This is what we're looking for. And then the sum has to be negative 2, that B value. Okay. 2 numbers. Product needs to be negative 3, but the sum also needs to be negative 2. 2 numbers. All right, let's think about this. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So the numbers are negative 3 and positive 1. So if you like, we can erase this and let's go back and recall. A is 1 is an important detail. We'll see in other examples. But this is going to be x minus 3 times x plus 1. Don't forget, those are the numbers we found in that exercise here. So this is the factored form of this trinomial here. Number 17, again, we have that A value being 1, B value being 6, and C being 5. So I'm going to write down my A value is 1 because it's not always going to be 1, and we'll see what we do when it isn't. But so far, it's nice and easy peasy. So 1 times 5 now is 5. This is the A times C part. B, though, is positive 6. So we're just going to notate the value B here, positive 6. And this is what this information now means for us again. Okay? We need 2 numbers multiplied together. Product is 5. And whose sum is 6. So if we go through the pair of numbers whose product is 5, we can say 3 times 2. Oops, sorry. Product is 5. I guess it's 1 times 5, and that's going to be a 5. And then a 1 plus 5 certainly is 6. So it looks like we found that pair of numbers right off the bat. 1 and 5. And again, since A is 1, we're done. So we can say this just equals x plus 1 times x plus 5. You have just factored by the crisscross method. Keep in mind, it was the numbers found in that exercise, 1 and 5. Number 18. A is 1, B is negative 1. So here's my A, here's my B, here's my C. So we need two numbers multiplied together whose product is, we got to get that A times C, 1 times negative 20. That product is negative 20. The sum, again, is negative 1. Okay, what does this mean? It means the following. We need two numbers multiplied together. The product needs to be negative 20. And the sum needs to be negative 1. So we got to stop and think again. What two numbers multiplied together is negative 20, but when added is negative 1? Let's see. Remember, one of the numbers has to be negative, because the only way you can multiply two numbers and have it be negative is if one's negative. So 4 times negative 5 is negative 20. And then 4 plus a negative 5 is, in fact, negative 1. So the pair of numbers are 4 and negative 5. Don't forget, A is 1. That's an extremely important detail. We'll see why. But we're actually done factoring if we just use these numbers. X. That 4 is positive, so put plus 4, and the 5 is negative, put minus 5. And there you go, ladies and gentlemen. Number 19. A, B, and C. So we need we need to multiply A times C here. Again, emphasize that A is 1. So this will be 1 times negative 6, which is negative 6. That's the product of A times C, right in here. And then B is just a positive 1. We just notate that what the value of B is, just by reading it off the trinomial here. It's the B value, and that's going to be 1 here, just by reading that. Okay. So, again, I need two numbers whose product is negative 6 and whose sum is positive 1. So, again, the only way you can have a product be negative is if one of the numbers is negative. And then notice this, 3 times negative 2 is negative 6, and then 3 plus negative 2 is a 1. So the pair, meaning two numbers, is one is 3, the other is negative 2. And because A is 1, you're done factoring. Just use the numbers that you found. Positive 3, negative 2. and you factored. This is factoring by the crisscross method. Now, I know this is review, and you might say, boy, Mr. Judge, you're doing a lot of this review. Yeah, well, maybe it's needed. So again, we got A is 1, B is 12, C is 36. So A times C, 1 times 36. And that is 36. And then the B value is a positive 12. So we just notate positive 12. We put it down here. So this becomes an exercise again in finding two numbers. The product will be 36, and then your sum is 12. So we got to think about those pair of numbers, a pair whose product is 36 and whose sum is 12. Now, turns out 6 times 6 is 36. 6 plus 6 is 12. So both of the numbers are 6s here. And again, since A is 1 over here, we're done. X plus 6 times X plus another 6. The pair is the same. So there you go, ladies and gentlemen. Easy peasy, lemon squeezy. A, B, C now. Again, A is the value 1. So we take 1 times negative 3. So your product is negative 3. Your sum is negative 2. So we need two numbers multiplied together. Product is negative 3. Sum is negative 2. It's the crisscross method. Product's negative 3. Sum is negative 2. So, looks like it's going to be negative 3 times 1 gives that product of negative 3. Negative 3 plus 1 gives the sum of negative 2. So, negative 3, positive 1 is the pair of numbers. And because A is 1, it turns out we're done. We put X minus 3 times X plus 1. Again, keep in mind you are using the numbers you just found in that exercise. Keep the signs. The 3 is negative, the 1 is positive. Okay. A, B, C again. And we can see A is the value 1. C is 5. So 1 times 5 is 5. B is 6. So again, we need two numbers multiplied together. The product needs to be 5, and your sum needs to be 6. Two numbers multiplied together, product is 5, sum is 6. And this kind of seems familiar. I don't know if we've done it already, but we know 1 times 5 is 5. 1 plus 5 is actually 6. So 1 and 5 are the numbers. And again, because A is the value 1, x plus 1 times x plus 5 is your answer right in here. There it is. The crisscross method. Now, that brings us to a question here that's different. You're still looking at this trinomial here, ax squared plus bx plus 5. Okay, still a trinomial. But if we identify the values now, A, B, C now, we're going to notice a few things here. A is a value 2. C is negative 3. So I'm going to write it down this way. A is not 1 anymore. A is 2. This is going to be slightly different, but let's just remember this idea, okay? We still take 2 times negative 3. That's going to give us negative 6. So that product of A times C gives us negative 6. The sum, we just look at the B term again. Negative 5 for that B term. So we'll put that negative 5 here. And we're going to go through the same exercise that we have been going through. Meaning we need two numbers whose product is negative 6, whose sum is negative 5. We need those two numbers. And I'll write it down again. Product, negative 6. Sum, negative 5. It looks like, again, negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Negative 6, positive 1. So, ladies and gentlemen, those are the two numbers that we are looking for. Now, this is pretty much the same as what we've been doing for the rest of these examples. Now, here's the difference, though. Typically, we would say x minus 6 times x plus 1. This is your answer only when A is 1 here. The problem is A is not 1. A is the value 2. So this is where this process changes, okay? Because A is not 1. A is 2. Go to the numbers you found divide them both by 2, the a value. Since a is 2, you divide both of the numbers by the a value, and in this case, it's 2. Okay. And then notice what happens with that division. If I said to you, just focus on 6 divided by 2 and 1 divided by 2. 6 divided by 2 is a nice whole number, x minus 3. We can do that division. The problem with 1 divided by 2 is it is not a whole number. 1 divided by 2 will give me a decimal value. Okay? 6 divided by 2 is a nice whole number, but 1 divided by 2 is a decimal. And you say, what is the decimal? Well, the decimal is going to be 0.5. Okay, 6 divided by 2 is a whole number of 3, but 1 divided by 2 is a decimal value. You might say, I don't believe you. One divided by 2 is not a whole number, it's a decimal value, 0.5. All right, let's just write some more information down. So, to say to you, what in the world are whole numbers? I'll use a W for whole numbers. 0, 1, 2, 3, 4, and so on. These are whole numbers. This is what we want to see in that division. And when we don't see it, like in the 1/2, move the a value in front of the x value. So a is now here, and just write down your x plus 1. And then, ladies and gentlemen, guess what? You're done. This is what you always do when a is not equal to the value 1. Hey, we lost our connection. All right. All right. Looks like the iPad crashed. Too much factoring. All right. Looks like it didn't even put that down. So, okay, we crashed the iPad. So let's do it again. 2 goes in front here. So that's 2 x plus 1. This is what you do when a is not 1. This is your answer. There you go. This is a review of the crisscross method. Let's try that again. A, B, C. A is 3. A is not the value 1. Okay. Three times 6, ladies and gentlemen, is the value 18. Okay. So we take that product, AC, and then we just notate what B is. B is here, negative 11. All right, let's go through the exercise. two numbers. Product is 18. Sum is negative 11. So this is an interesting situation because both numbers multiplied together needs to be positive. That only happens if both numbers are positive or both are negative. Because a positive times a positive is a positive, and a negative times a negative is a negative. But what's interesting here is the sum is negative. So if the sum's going to be negative, that means both numbers are negative. So two numbers multiplied together that are negative that give you a 19 or 18. Negative 9 times negative 2 is a positive 18, but negative 9 plus negative 2 will be negative 11. So that's negative 9 times negative 2. These are the two numbers. All right. So we would have been done if A was 1. A is not 1, ladies and gentlemen. A has the value of positive 3. So what we always do is divide, again, the numbers we found by the A value. And in this case, it's positive 3. Doing arithmetic right in here. We know 9 divided by 3 is a whole number. It's 3. But 2 divided by 3 is a decimal value. It's not a whole number. Move that number up here, and you get 3 now times x minus 2. Ladies and gentlemen, this here is your answer. And you do that when A is not 1. A is the value 3 here. So you're done there. You have factored by the crisscross method. Let's just put it up here so you can see it all together. Okay. There it is. $25 now. Again. A, B, and C. A is 3. A is not 1. So 3 times 5 gives you a nice 15. What's your B value? 16? Okay. Okay. Just going through the process again, we need two numbers. The product of those two numbers is 15, yet the sum of these two numbers will be 16. Remember, A is 3 now, but we're going to go through that same process. So, turns out 15 times 1 definitely is 15, and then 15 plus 1 is 16. So, 15 and 1. These are the numbers here. However, We're not done. We're not done because A is not 1. A is the value 3. So we're going to have to divide both of those numbers here by 3 and then find where we get a whole number answer. Here again, 15 divided by 3 is 5. And then 1 divided by 3, that's not a whole number. So you're going to put there a 3 in front of that X. Don't forget to add 1. So, ladies and gentlemen, there's your conclusion there. So I won't put it back up here. Don't really need to, but you guys have reviewed this factoring by the crisscross method. Pretty good stuff. 26. A, B, and C. A is 2. A is not the value 1. Two times negative 5. A times C. Answer is negative 10. Excuse me. And then just look at this. Find the B value, which is 9. So we need two numbers multiplied together. Product is negative 10, but whose sum is positive 9. Okay. Two numbers multiplied together. Product is negative 10. Sum is 9. Well, in order to get a product that's negative, one of them is positive, one is negative. Looks like it's going to be 10 times negative 1. And that's negative 10. 10 plus a negative 1 gives you a positive 9. So we got 10 here and negative 1. These are the two numbers. All right. So we'll put down x plus 10 and then x minus 1. A is 2. So we have to divide both of those numbers we found by 2. See where there's a whole number answer. See where there's a decimal answer. And 10 divided by 2, by the way, is a nice whole number. So it's x plus 5. And then 1 divided by 2 is a decimal. So we move that up in here. So this would be 2 now times x minus 1. And I kind of get a little, I don't like that little dash. Ladies and gentlemen, there you go. Crisscross method. Okay, number 27. A, B, and C. So A is 3 now. A is not the value 1. Three times 20 will give you 60. The B value now is 19 just by looking at that. So we just look at this and say, oh, B is 19. Okay, it's going to emphasize that A is 3. All right. Two numbers multiply together. Product is 60. Sum was 19. 15 times 4 is 60, and 15 plus 4 is 19. So we found the two numbers, 15 and 4. Okay. Now again, we think we're done, but we're not. X plus 15, X plus 4. So A is the value 3. It is not 1. We got to divide those numbers by the A value. In this case, it's 3. So 15 divided by 3 and then 4 divided by 3 here. 15 divided by 3 is 5. And then we're going to move this 3 up here because 3/4 or 4/3, sorry, is a decimal answer. It's not a whole number. So this will be that 3 there with the X plus 4. There you go, ladies and gentlemen. Factored. That leaves us with the last one, number 28. Oh, good. A, B, C again. So notice A is the value 4. A is not the number 1. So we have to take 4 times negative 5, which is negative 20. A times C, negative 20. The sum here is the B value. The sum is negative 1. Product is negative 20. The sum here is negative 1. So I need two numbers multiplied together is negative 20, but when added is negative 1. Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. So we'll put negative 5 here, positive 4. Okay. So this is x minus 5 times x plus 4. However, A is positive 4. It's not 1. So we have to divide both of those numbers by 4. We get a decimal answer. 5/4 is a decimal, but 4/4 is not. So that means we put the 4 in front of this x. There you go. And we simply write the whole number of 4 divided by 4 being 1. So there you go, ladies and gentlemen. All right. So I hope you guys enjoyed this demonstration, this review of the crisscross method. It's a review of factoring. Put that 4 a bit lower there, and there you go. So ladies and gentlemen, take care. I'll send this to you. Have a great day.